Thanks for setting the stage. We're going to shift now to a California leads panel, and I'm actually going to be doing a little cameo in that. So I'm going to hand over to our friends from Department of Energy. Stephen Hendrickson is going to take over as the moderator. Thank you.
Great. Am I all set? Can you hear me okay? All right. So thank you, Danny. My name is Stephen Hendrickson. I am a program manager in the Office of Technology Transitions at the Department of Energy. Just want to say thank you to Danny, to Dr. Yika, and all the organizers for giving me the opportunity to present here. And I think we have a great panel set up. And I know the collaboration on what we're trying to do with the Energy Storage Grand Challenge and all the leadership that the Bay Area Battery Summit and New Energy Nexus has shown is much appreciated. I think it really, for us, has been a nice opportunity to give some regional context and richness to our thinking at the federal level. I think we have an excellent panel set up ahead of us here with, Danny Kennedy will be presenting here shortly. Tony Van Buren, the Deputy Division Leader for Science and Technology at Lawrence Livermore's Materials Science Division, will be presenting. Jeff Chamberlain, the CEO of Volta Energy Technologies, which is actually financing energy storage companies, will be sharing his perspective. And then finally, Virginia Klossmeyer, who is the founder and CEO of Silvatex, which is an innovative green nanochemistry company that is operating directly in the battery technology space. So really giving us some specifics of what things look like at a regional and local level on the ground. And I think for us, again, complementing how we're trying to develop a national strategy and show national leadership with what things really look like for folks at the labs, the experts at the labs, the financiers, the companies on the ground that are really the heart of what this effort looks like. So I'm really looking forward to a great discussion. What I would like to do is, I think Deputy Assistant Secretary Pessin did a great job of laying out the Grand Challenge as a whole. And I think what I would like to do is kind of set the stage for this discussion by adding a little more with regard to the tech transition component of the Grand Challenge that I focus on in particular. So in the Office of Technology Transitions, led by our director, Connor Prohaska, who is also the Chief Commercialization Officer for the department, we really work across the board, across all DOE programs, across all 17 national labs to accelerate the commercialization of technology. So we're doing that for working on energy storage here, but we also work on a whole host of other areas. So within that context, alongside our Deputy Director, Marcos Gonzalez Harsha, we have been supporting the tech transition pillar of the 5 pillars of the Grand Challenge, really bringing that commercialization element, highlighting that, and really trying to bring as much sort of capacity to bear on that component of the challenge. So as you saw from, I won't spend too much time on this, but from Deputy Assistant Secretary Pessin, the Grand Challenge is unique in that it brings all the different relevant offices and labs working together, coordinating activities, figuring out where are the unique capabilities that the department has to work together to support U.S. leadership in energy storage technologies. That includes the battery storage technologies we're talking about today, but also includes other potential, both from an R&D perspective, of chemical thermal storage, bidirectional electrical storage, but also this idea of how you might utilize flexible generation and controllable loads to to enable new services and capabilities. So within the Grand Challenge, we really break it out across 5 areas. We're working very closely with one another. So as again, Deputy Assistant Secretary kind of highlighted, tech development is really the R&D piece. There's a number of offices doing research and development relevant to energy storage and battery technologies. Manufacturing, I've heard already come up several times in today's discussion, and that really gets called out both through our advanced manufacturing office and then through other offices and cross-agency initiatives regarding critical materials and other activities. Tech transition is the one that I help with my colleague Marcos Gonzalez Harsha to lead. Policy evaluation is really about developing the tools and capabilities, a lot of these through our national labs, but other avenues as well to provide decision makers with the tools they need to understand how a technology will operate in a system or how a system might operate or evolve over time, and how energy storage with different sort of capabilities and technical requirements would facilitate that or enable new functionality. And then, as also was highlighted earlier, workforce development is a critical concern, both for where the system is today and also where it's going, and ensuring that we have the talented base capable of making this reality possible. So I think one thing that's really important to highlight about the Grand Challenge is this use case framework, is how we've identified sort of 6 use cases where energy storage technologies may provide a service. And I think for DOE, we spend roughly about $20 billion a year on research and development sort of across the board. And I think what's been important about this framing is to really think about what is the services or sort of problems that energy storage can solve or battery technologies can solve, and then working back from there to say, okay, well, what markets would those technologies be operating in? Who are the current technologies or cost drivers in those markets? And then what does that imply for the R&D strategy and the manufacturing strategy to get costs and performance to where they need to be so that you do see commercial adoption? And so that just really shows how all these different pillars of the 5 pillars are really working in concert to think about how all those pieces fit together. So the high-level framing that we rely on here is this: innovate here, make here, deploy everywhere. And I think that while it's the devil's in the details, I think that it's really highlighting that U.S. leadership in energy storage consists of multiple components. That what leadership in innovation looks like is different from leadership in manufacturing, which is different from what it takes to deploy new technologies both domestically and internationally and have sort of market adoption. So I'd like to kind of expound on those just a little bit to say what does innovate here, make here, deploy everywhere look like from a tech transition commercialization perspective. And I would say within the innovate here domain, what we're really highlighting is the financing of early stage technologies. This is both done through the government, through the national labs are actively involved in this. There's also a lot of private sector activity, as you're going to hear from our panelists today, that this is not, this is a combination, it's a whole ecosystem of financing, but we need to ensure that a number of different technologies are receiving that sufficient funding to get their development underway, to give us options for how we might be able to deploy them in future scenarios. At the same time, there's sort of an iterative process where you're looking for potential applications for those technologies. That goes back to these use cases of like, what are the current problems that energy storage might solve, and what are problems that may be emerging over time that 5 or 10 years from now we want to be far enough along in our R&D pathway that we have a range of options for decision makers to deploy to solve problems. For those technologies to get market adoption, we need to think about what business models will make that happen. What are the current business models? How are those adapting over time? I mean, think about transportation, electric vehicles, and all the dramatic changes we're seeing in the business models and transportation, and what implications do those have on price sensitivity, the cost of technologies, et cetera. And then sort of across the board, what are the size of these markets, both domestically and internationally? So if you're a company trying to gain a toehold in some of these areas, where might a beachhead market be available to you domestically or internationally that could help you get enough scale that you can, again, drive enough investment into your company? From there, I think it's complemented by this sort of make here idea. And one thing I wanted to highlight, I heard earlier this question about ARPA-E's role, and I think an interesting program for highlighting here is the Scale Up. It's all capital Scale Up if you search for it online, and that is ARPA-E has identified $75 million for funding the development of product line to go from like bench scale to pilot scale. So identifying these challenges, and of that 75 million, 20 million, they just awarded the first 25 million, and 20 million of that went to a battery technology company, Natron Energy, for domestic manufacturing of sodium-ion batteries. So that's just an example of where these different programs are trying to find different challenges across the value chain or the innovation chain to help de-risk technology and bring it to scale. And just acknowledging also that there's sort of different types of risk. There's this broad macro market risk that domestically, internationally, trying to understand where markets are, where they're going. What does that imply for the growth of your company? There's production risk about if you're going to build a plant, is that plant going to be able to produce your widget at the price that you need it to be at in order for that technology to sell into a certain market? And then there's project risk, and that is, if you're actually building a energy storage facility, say in a particular location, can you get that on time and on budget, and can you, reduce risk enough around that project that you can get sufficient investment? And so part of what we do is just help to highlight that these risks are different, and that the different government levers available from a whole host of partners, work in sort of concert to address these different risks. And that's where, going back to the earlier points, we want to hear from industry. We want to hear from folks, on the session today for, what are you seeing, and what are ways that we can better target our tools and our toolkit to help support all the work that you're all doing, on the ground on a daily basis. And then finally, deploy here is just sort of looking at where are the markets, going back to these 6 use cases, recognizing that each market will have different technical and cost requirements, that in some cases, international markets may, in sort of the short-term or long-term, be larger than domestic markets. So if you're a company that's really trying to succeed in a globally competitive market, you need to be thinking about both the near-term and long-term, where's your sort of competitive advantage. That we want to have this multi-pronged approach, that we are funding, a range of technologies. We're looking at a range of different markets. And that there's a number of different decision makers that are relevant to keep in mind as, we're developing our strategy, and then hearing from all these different groups of people to make sure that what we're doing makes sense. And I think, one thing I didn't highlight earlier, but just to point out that I think what's really exciting for us with this session today, and with this panel in particular, is that so much of what's going on is at sort of a regional or local level. So some of these use cases may have more or less relevance to a particular, city or community, and that makes complete sense. And we're not saying that every, region needs to be concerned with every use case, but where there are specific use cases that do resonate at a local level, that's really where the action is, to understand how these new technologies can address problems that have been identified at a local level, and how, we can support that with R&D and company development to meet those needs. And so that's where we kind of take back that perspective from this panel, from this group convening today, to help think about what are we seeing at local levels in the Bay Area and maybe other regions of the country, that helps inform how at a federal level we can support that. So I think the other thing that I just wanted to highlight, which was mentioned before, was just how do we get kind of connected to this? What are opportunities for engagement? And that is another area that within our technology transition track, we really push, that we often may not be the office that has the answer to your question, but we can help you navigate that bureaucracy, so that, there's a number of different program offices that are doing research and development. There's a number of different labs. I know there's folks on here today from SLAC and Lawrence Berkeley, and from Lawrence Livermore, and from Pacific Northwest Lab. There's a lot of people across the DOE ecosystem that are heavily involved in this, and we really appreciate all their work on this. And what we want to do is just to facilitate that connection, so that if you're seeing opportunities for us to support what you're doing in the community, that we help you find that right person to talk to. So feel free to engage with me directly, and I can kind of put you in touch with the right person. And also just, go to our site to read more. We have both a roadmap for the Grand Challenge, as well as a market report that kind of, in the same vein as what you saw from Bloomberg and from RMI, some great sources out there that we rely on also, but trying to look at that from a DOE cross the board strategy perspective, where we bring in all that different market intel and say, now what does all this perspective mean for all the R&D work, all the commercialization work we're doing at a federal level? So, we're only as good as the perspective we get from all you. So I think with that, I'd like to pass it off. I think Tony Van Buren from Lawrence Livermore National Lab will be our next speaker, and then each speaker will give their own presentation, and then we'll open up for some discussion and for some Q&A.
Okay, I think.
Did I get the order wrong?
There
you go. Great. Thank you, Tony.
Okay, I think it's going to come back to me. Sorry. The order was unclear, but I'm going to just jump in. As you can see, I've taken off my coat and rolled up my sleeves because I want to get down to work now, and talk about how California is leading a lot of this amazing work that's just been laid out by DOE to be done, and all this opportunity space that we can fill, as we heard from our friends at RMI and Bloomberg New Energy Finance. So I hope that you can see my screen. I'm just trying to share this PowerPoint about our energy storage program at New Energy Nexus. And I want to thank Dr. Yi Ke, who helped prepare this summary for me to present. She's busy running around backstage and hand-holding all of you all in the audience. There's hundreds of people online asking questions and having needs. And so she's done this, and you'll get to meet her later in the conversation tomorrow. I should also just call out, a lot of connectivity here with what's been mentioned. Stephen just talked about Natron Energy as a great example of a company DOE's supported. We'll be featuring them tomorrow as well. But just to talk a bit about how California is really the tip of the spear on energy storage innovation in America. We at New Energy Nexus manage the California Energy Commission's CalSeed Fund and a program with the UC Office of the President, CalTestBed, the University of California system. So we've been doing CalSeed for about 4 years now, just did our 100th investment in a company, and many of those companies, like this year, I think at least half a dozen of the 28 concept awardees were in the energy storage sector. I mean, the winners of this year's Clean Tech Open were CalSeed companies that had come up with our support. We had Core Shell Technologies as an example, winning the national prize at CTO. We had the NZinc as the winner of the most popular amongst the constituency there. So we've been fostering and funding storage companies in California for years here at New Energy Nexus with CalSeed. And we have this new program, the CalTestBed initiative, which is about placing startups at UCs to do verification and measurement processes, and we can pay for that. So the students and faculty that get involved in the certification of your prototype basically are funded to do that, and the UC is being engaged in the commercialization of technology. We've already done over a dozen of these placements, and several of those, particularly at UC San Diego, were in energy storage companies. As well as that, we run a more pure play energy storage program known as CalCharge. That's the host of this event with you. It's been going since 2012. It's a public-private partnership, really, in that we have this these contracts or CRADA with the national labs in the Bay Area, SLAC, Lawrence Livermore, that we're with today for Babs, and Lawrence Berkeley. And we run projects with PIs at the labs, and you'll hear from Virginia at Silvertech shortly about one such, but we've done Bosch at SLAC and a dozen or more at Berkeley and so on. We've also, in the last couple of years, been promoting the generation of our own homegrown green lithium at a place called Lithium Valley in the Salton Sea, and that'll be the subject of a panel later today at 1:30 p.m. this afternoon. If you want to know more about CalCharge, I really recommend that you go to the roundtable at 3 p.m. because that's where you can meet the leads at the labs that help host you and find you PIs to work with and can help navigate the bureaucracy using our CRADA as members of CalCharge. You get the Bay Area Battery Summit, you're here. I won't talk about that anymore. I do want to talk a bit about the EV and battery challenge that we're running again this year with LG Chem, partly because it speaks to the fact that California is really leading, because LG Chem has become a big partner of ours, and with Lawrence Berkeley National Lab in particular, through CalCharge, in a lot of their innovation R&D research. And that's not saying nothing. They're the largest, at least in Q1, the largest maker of lithium-ion battery cells in the world, and their battery packs are in everything from the Bolt that I drive around to Hyundai and Kia's cars and many others. We've been partnering with them since 2018 to do these open applications for startups to apply to run pitches and so on and showcase their ideas with this BMOF in the battery manufacturing space. And they then go into an innovation program with them that we managed. This year, we added Hyundai and Kia, the other Korea-based giants, the third largest OEM in the world, shifting rapidly to electrification. And so we have the EV and battery challenge, whereas previously we were just looking at battery technologies with the startups that we bought to LG. And what this battery and EV challenge allows is for paid proof of concept projects to be conducted with these large corporates, building strategic partnerships with them to invest in their products and commercialization trajectories, and to validate their technologies in real world corporate settings like the largest manufacturer, LG Chem, and in a big OEM as well. So just to quickly overview it, we had over 200 applications, twice as many as we had just a couple of years ago, which speaks to the market, the startups around the world, from 37 countries. So again, that was a growth in the number of applicants and places they came from, which demonstrates just how far and fast this is growing. If you want to get a sense of it, it really was quite a diverse set, and not just Korea and the US and Europe, as we heard from Bloomberg New Energy Finance, but countries like India are really scaling their approach to electrification of vehicles, and therefore their battery technology sector is growing quickly as well and applying to global programs like this. This is our current timeline. I won't dwell on it, but you get the idea that we've done a major solicitation this year, attracting a couple hundred applicants. We down selected them just recently and are currently in the sort of pre-workshop prep stage for getting to grips with how those technologies and those companies might partner with LG Chem and Hyundai and Kia. So it's a very exciting time. If you want to know more about the EV and Battery Challenge, go to evbatterychallenge.com. But if you want to know more about New Energy Nexus, as I mentioned earlier, you can sign up to our Slack and newsletter and get involved with our program in lots of ways. Looking forward to the conversation. Thanks for letting me sort of make the case that California is leading the world with the largest battery manufacturer, LG Chem, and Hyundai and Kia as well. And I should have mentioned Dr. Jim Kim, who spoke last year at the Bay Area Battery Summit at Stanford, is our key partner there. Over to you, Stephen.
Great. Well, thank you for that, Danny. I think next up we have Tony Van Buren, the Deputy Division Leader for Science and Technology at Lawrence Livermore National Labs Materials Science Division. He's going to talk a bit about what things look like from the National Lab perspective on the battery ecosystem in the Bay Area. Take it away, Tony.
Great. Thank you, Stephen. I'm really excited about being able to give an overview of the energy materials efforts at Lawrence Livermore National Lab, particularly to this audience that is so diverse and people may not be familiar with the efforts that were going on at the lab. So the mission at Livermore is to strengthen national security through world-class science, technology, and engineering. We have mission focus areas in stockpile stewardship, weapons of mass destruction, threat reduction, and multi-domain deterrence. But an area that you may not be as familiar with is that we have a mission area in climate resilience and energy security. And obviously that's where I'm going to be focusing my talk today. So our energy materials work enables and benefits from our broader portfolio of work. This was touched on earlier today by the opening address by our director, and he mentioned the spin out, spin back effort. So what does that really mean? That means that there's material systems and capabilities and infrastructure that we've had to develop to meet our mission space for programs. And these material systems are directly applicable to the spin out in energy materials. So this gives us a capability that we've had to develop to meet our mission space that is directly applicable to energy materials, where we then try to push the forefront of science in that area, develop and expand on these capabilities. And what we then do is actually spin that back in, these developed capabilities, into meeting missions at the lab. So it's a very synergistic development, particularly for bringing in new technologies and primarily new people into the lab. Energy materials is an attractor. It brings the best and brightest to the lab, and we can bring in people to work in these energy materials, and then they get an idea of the wealth of things that are going on at the lab and spin both capability and new people into the lab. So obviously we don't do everything, but there's a number of material systems that we really focus on at the lab. So I want to just touch on some of these. We have significant efforts in working on solid state batteries, high energy density supercaps, zinc electrode batteries, that's both zinc air and zinc manganese oxide rechargeable batteries, and looking at geometry optimization in flow batteries. We have a large effort in architected and optimized structures. Now, I think this really makes us somewhat unique compared to other national labs, in that what we're trying to do is meet performance metrics in batteries and energy storage by optimizing the structure. So doing a thorough topology optimization, determining what structure is going to be most efficient and most beneficial. And then what we do is we map it to the exquisite 3D printing capabilities that we have to actually print that prototype and then test, is it actually delivering on what the optimization is doing? So it's a different approach. It's not, let's say, I'm building a new material to meet a specific goal. I'm optimizing the structure, putting it together in 3 dimensions. Its microstructure and morphology, etc., are meeting the design goals. In that area, we do a lot of work on porous electrodes and structural batteries. Structural batteries, in this case, is a battery system that actually is also a structural component in a unit. As was touched on earlier, we have a significant effort in computational material science at the lab, using some of the top computers in the world, looking at interface and degradation models, particularly multiscale models of reactive interfaces, coupled theory and in situ characterization, and particularly modeling the degradation processes that are going on in batteries. And new in this area is actually we're starting to model the actual processing conditions. What processing conditions actually give you optimal structures? Synergistic with all this effort is efforts that we're doing on hydrogen-based grid storage, thermal energy storage, exploiting the testing facilities that we have for explosive-based testing, so safety testing of battery packs. And internal to the lab, we have needs for various battery systems, particularly for DoD and NSA applications. These are particularly primary batteries, but they have to meet the metrics of being able to stay on the shelf for up to 25 years and then being able to use them. Excuse me. So one of our capabilities is LEAF, the Laboratory for Energy Applications of the Future, a multidisciplinary center at Livermore that develops disruptive energy technologies. Now that's beyond just batteries and energy storage. In LEAF, we house our effort on water purification, our effort on the hydrogen economy, rare earth materials, and our efforts in the Critical Materials Institute. So I encourage you to go to the website leaf.llnl, and that gives you an overview beyond just batteries of all the stuff that is being done at Livermore in terms of energy storage. And at a high level, LEAF coordinates and accelerates the development of scalable optimized structures, i.e. this topology optimization that I've been talking about, at the intersection of porous materials, chemical reactions, transport for energy applications. Also new is the Advanced Manufacturing Laboratory in our open campus. The Advanced Manufacturing Laboratory is designed for collaborations with industry and outside partners. It has 10,000 square feet of lab space. It opened up last year. You can see the picture in the bottom here in the circle is what the labs looked like a year ago. And now you can sort of see that we're in full operation. Again, this AML, the Advanced Manufacturing Laboratory, is designed for the spin-in, spin-out business model that will benefit both industrial partners and internal LNL programs. And again, in this effort, we have a significant footprint in energy materials in the Advanced Manufacturing Laboratory. And again, it's in the square box here. We predict optimized structures that will meet performance metrics. We print those structures and then do prototyping testing. This facility is part of a larger effort to closely integrate our lab with industry, and primarily of most important, it's outside the fence, the security fence in the lab. So getting on site into the advanced manufacturing laboratory is much easier. You don't have to go through the same amount of security clearances. It's very close to our new computational material science center. And there's future labs being developed and the new academic collaboration center. So one of the areas that also in here represents our high performance computing initiative. So these high performance computing facility investments are in cross-cutting material simulations guide our improvements for energy storage materials. So the over on the left, the High Performance Computing Innovation Center is actually located on the open campus. And some of the areas that we're working in there is understanding multiscale simulations to understand processing science, in this case for understanding the sintering and processing of solid electrolyte materials, understanding the degradation of materials, particularly degradation at interfaces between solid electrolyte and cathode materials or electrode materials, and understanding performance metrics that are met here. And if you take a look at the website here, this will give you more information of all the things that are being done in the High Performance Computing Innovation Center. This is actually part of the Livermore effort, but across all the DOE national labs, there's something called the HPC4 program, and this is to accelerate collaboration between national labs and US industries to increase innovation and competitiveness. It started a number of years ago back with the HPC for manufacturing, as from the name, supporting manufacturing efforts and manufacturing industries at the lab. Went on to HPC for materials to develop new types of materials to meet the needs of US industry. And now we have HPC for energy. And I bring out two of the projects here. One is to develop new materials, separator materials. This is in collaboration with Sepion, I think, who's in attendance in the lab. And we're working with Toyota to develop new processing conditions for solid electrolytes. So there's many opportunities to work with Lawrence Livermore National Lab. I show in staffing here over on the right and the various capabilities. Just to blow our own horn a little bit, Forbes has identified Lawrence Livermore National Lab as one of the top 500 employers of the best places to work. And we're really interested in reaching out to collaborators and industrial partners, again, to push this spin-in, spin-out capability at the lab. And I believe I will pass it on now to Stefan again.
Thanks, Tony. Obviously, there's a ton of really exciting stuff going on at Lawrence Livermore National Lab. Appreciate your presentation. I think we'll have some more questions in the Q&A, but for now, we'll pass it on to Jeff Chamberlain. Jeff is the CEO of Volta Energy Technologies, and Volta is really focused on leveraging their deep technical expertise to advance investments in energy technologies, particularly looking at energy storage, where they do due diligence on energy storage technologies to connect innovators with investors. So with that, excited to hear Jeff's perspective on the Bay Area.
Great. Thanks so much. Am I on now?
You are.
Great. Well, thanks everyone. Thanks for hosting this event, and thank you for inviting me, and thanks in advance for your attention. I just have a few minutes to describe the investor perspective. And for those that don't know, I appreciate what I hear from Tony at Lawrence Livermore, and it sounds like Livermore and the labs have come a long way, as well as Berkeley and Argonne and Oak Ridge and Sandia, et cetera, since I left in 2004. I used to run the battery energy storage research at Argonne National Laboratory and was in charge of licensing, in particular the NMC materials that have been licensed to LG Chem and BASF and General Motors and others. And my point there is just that I have left the laboratory system wherein we worked much like Tony just described to help nascent technologies become viable, and in that process help companies become viable as well. I have since flipped over to the other side which is by my way of introducing that as a venture capitalist, we have a fairly cold-hearted look. We're forced to have a cold-hearted approach to deploying capital, meaning we need to understand that if we invest $1, nothing I'm about to say you don't already know, but I want to reiterate some profound points here as a startup transitions from government funding and assistance in labs and universities all the way to full-on venture funding. Our look is significantly more about if we put $1 in today, when and is that likely to be worth $5 or $10? So the frame of reference of my entire talk, and it's only 4 slides here, comes from that perspective. And there are just 3 points I want to make. First, why batteries and storage? Why is now the time? And secondly, what constitutes storage technology? What do we think of Volta? And by extension, what do we believe the audience should think of? Department of Energy, startups, the national labs. What is a battery or storage tech? And then finally, what is our target stage? And all of that, yes, I'll be talking about Volta, but really the idea is to talk about things from the investor's perspective. Most of what's on this particular slide here is very obvious to anyone that's listening into this call. That battery technology is mature and experiencing market pull. I just want to remind everyone that the first lithium battery techs were invented at Exxon in the 1970s and commercialized by Sony in 1992. And ever since, they've been marching down the cost curve since the 1990s. So like any new physical nascent technology that's impactful, it takes decades, I guess is my point. But the tipping point has already occurred for batteries. And if you look at the right side of this particular slide, there's not enough room for all the logos that I could put there for large and small companies around the world that are intending to deploy either storage on the grid or to re-engineer, if you're an OEM, re-engineer your entire value proposition and start selling electric vehicles. And I put Tesla in the middle here because Tesla really deserves a lot of credit for driving this change. Having started the company in 2004, they've come a heck of a long way, and not just on vehicles. That picture down below is the largest stationary battery installation on the planet in the outback in Australia that is full of Tesla cells and batteries. But part of the reason I start with this slide is prior to joining Argonne National Laboratory in 2006, I worked for the private sector in the microchip, in the business of integrated circuits. And so my point to the audience here is we are, I believe, 10 years ago, we were where the IC industry was in the 1980s, meaning there was a coming boom in the 80s and 90s that every player on this list, from VW and Ford to NextEra, National Grid, British Petroleum, Equinor, is making massive investments in battery and storage tech. Much like what happened in the 90s, there was an obvious market pull coming for integrated circuits. And what ended up happening was innovations were gobbled up by the big players. So if you're doing a startup, think of a path to exit for investors like Volta or Kleiner Perkins or Prelude or Breakthrough Energy. You must think about that exit. And my point to you here is a viable exit is to be acquired by a company like LG Chem or Panasonic or maybe even one of the OEMs. Or energy providers, or Siemens. The list is long. My second point I want to make is that the opportunity goes far beyond the battery or the storage device itself. That we believe that not only is energy storage about more than lithium ion, it's also about more than batteries. So that these are just examples from Volta's portfolio. Ionic Materials is a plastic solid state electrolyte and separator that conducts lithium ions at room temperature. Well, we're invested in that company. It's non-flammable material alongside entities like Hyundai, Nissan, Total, LG Chem, A123. The list is long. Hitachi. And we like companies like that because they serve the value chain above them and they are co-developing their products with their customers. So it's not a battery company per se, but it's an innovation that, if commercialized properly, will have dramatic impact and increase the value across the board of storage on the grid, as well as batteries and vehicles. Natron, we just heard mentioned earlier. We're invested in Natron. It's a sodium ion battery company that came out of Stanford about a decade ago. Also an ARPA-E company, as well as Ionic Materials is an ARPA-E company. We co-invested alongside ABB and Chevron because while their beachhead market is backup power and grid storage, but backup power for data centers, their battery, by our modeling, is the perfect battery for fast charge of electric vehicles, which is why Chevron is invested. So if you charge a vehicle from a battery on the ground to the car in a DC to DC, you've already done the inversion from AC on the grid. There are various advantages from a cost perspective to have a perfect battery in that application. Again, expanding the view of what a battery is, we're also invested in something called Smart Wires, which coincidentally is also an ARPA-E funded company. Smart Wires is a microchip power chip device that senses and responds to power on a line. So transmission congestion is a real problem that gets worse when you introduce solar and wind distributed generation. And the traditional solution to this problem is to build more wires and transformers. This group has a system that costs between 10 and 15% the ordinary costs of solving the transmission congestion problem. It senses power in a line and either can automatically, on a millisecond by millisecond basis, pull power from an overburdened neighboring line or push power from the line that it's on if that line is overburdened with power. Now, that's a good example of something that's not a battery tech, but the reason it's in Volta's scope is it enables the adoption of renewables by lowering the overall cost equation for batteries on the ground. You need fewer stationary batteries if you're installing renewable gen where smart wires is installed on the transmission wires. To expand that further as what is our definition of a battery, these are our technologies that are not in Volta's portfolio currently, but it's just examples of things we're very interested in. And I heard Sepion, Tony mentioned earlier. Sepion is also on our list. It's not a company that's building a battery, but it is a company that's building a solid state electrolyte and separator that could enable solid state batteries. Same idea with Redwood Materials launched by J.B. Straubel. It's not a battery company, but if you recycle properly and you have urban mining of cobalt and nickel and lithium and aluminum and copper, you can reduce the overall cost equation for batteries. Same thing with NextGen. It's a gallium nitride on gallium nitride power chip that is significantly more efficient in its transfer of power from one device to another. So it's not a battery tech, but it can enable a lower cost battery equation, either for batteries on board vehicles or batteries and storage devices on the grid. And if you want to go really further out, a company like Turntide, that is a new electric motor technology that uses switch reluctance as a technique that for HVAC systems, it improves the efficiency of between 40 and 50% and does not require magnets that use rare earth elements that mostly come out of China. Now, that's not a battery tech, and it's adjacent to battery tech. But if you have HVAC systems that are 40 to 50% more efficient in their use of power, that can impact the overall storage equation for the grid in terms of the cost required of storage, and ultimately might also be used on vehicles. The efficiency improvement is smaller on vehicles, but ultimately may be used in vehicles as well. One last point, my final point I want to make. And this is, I hope you will hear this as kind of hand in glove from my prior experience working for the Department of Energy and what you just heard from Tony and Danny. Our aim is to invest in companies that are at the inflection point. Many venture capitalists you will hear, well, we only do Series A and B companies, or we only do Series C, D, and E companies. We don't look at it that way. The x-axis on this graphic is technology readiness level. So we have invested in a company that's at technology readiness level 5, for example, but it was an A round. Similarly, we've invested in E round companies that are at technology readiness level 8. And my point is that entities like Volta like to understand and collaborate with the DOE National Labs and entities like Danny's, like CalCharge, because the government and those other institutions, including LG Chem, all the way up to LG Chem and Hyundai, and BMW and others, are willing to invest in early stage companies where cold-hearted financial institutions like Volta are less willing to do so. So we carefully diagnose and determine how ready a technology is to penetrate the market. And that's where we invest. That can be pre-revenue, it can be post-revenue, but we aim for that inflection point. And I'll leave it there just to drive home the point that we are investing in companies that come out of the spin in and spin out type operation that Tony just described. Another example is Cyclotron Road at Berkeley, or Chain Reaction Innovations at U Chicago and Argonne. We love the fact that the government sees the opportunity, the economic as well as environment and national security opportunity to invest in nascent technology to innovate and manufacture in the U.S.
Thanks, Jeff. And I think your presentation serves as a nice sort of transition from what Tony laid out from the lab perspective into our final panelist. Last but not least, Virginia Klausmeyer. She is the founder and CEO of Silvatex. Silvatex is an innovative green nanochemistry company that looks to advanced technology to produce inputs to battery storage technologies that are make sense environmentally and can be local sourced. So with that, we look forward to your presentation, Virginia.
Wonderful. Thank you so much for having me. I'm hoping that my presentation is up and it's wonderful to be part of this panel. So thank you so much for the introduction. Again, I'm the CEO and founder of Silvatex, shorthanded to SVX, and we are sustainable chemistry for better energy. I think given the panel's discussion, I'm really hoping to give you a little bit of sense about what we do and why we do it, but really focus on how we got to where we are today and really accelerating our technology so that we can be part of this energy revolution in the near term. I am going to go through a few slides here and try to get through some of the initial intros and then get to some of the guts. So we all know the impact of climate change is readily apparent, and there's really a massive movement to renewable energy and zero emission fleets, and this is going to require thousands of gigawatts of batteries. Battery manufacturing is growing. We heard a lot from earlier presenters on seeing those markets grow and how substantial they are today. So there's really a huge opportunity to be part of this next fuel of the future is really how we see it. We are focusing on the part of the battery that is really the largest cost sink, the cathode. The cathode accounts for almost up to 50% of the battery costs, and is really the largest bottleneck when you're looking at battery manufacturing and trying to bring down costs and accessibilities. Specifically, we look at the cathode manufacturing improvements that are really key to reduce battery costs. So not to go into too much depth, but there's the lithium battery cell. The cathode makes up one of the key components along with the anode and the electrolyte and other materials. And when you look at the cost breakdown of the cathode itself, you have a large portion of that is the rare earth metals that go into the key material, but you also have a significant portion is the processing of those materials to get them into the cathode state that's needed for the actual battery. And one other key point is that these cathode materials are all fully integrated, and that's really important when you're looking at how do we solve to become part of the solution today and really drive down costs and increase performance for the industry. So we are focusing on really the processing cost is primed for optimization and really driving down the cost of immediate battery integration. So specifically, what do? We are really using our technology as a way to expedite some of the traditional cathode processing. The traditional cathode process. This is a snapshot of something that Tesla presented in their battery day. We were able to take the traditional process that uses a lot of water, there's a lot of processing steps, and there's a lot of waste. And what we do is we use the same type of materials that are currently used in industry and same type of actual chemistries, we have a reaction medium that we call micro-X, which allows for, one, a recycle loop of the material, two, it increases the rate of reactions. There's a lot fewer steps, which ultimately lowers energy cost and actual energy needs and overall cost itself. So you're able to have significant developments there. And one of the key pieces of the puzzle is really trying to figure out how you can integrate these new technologies into the current infrastructure in an effective way to accelerate the market access and integration as fast as possible. So what we've done has, using our technology, is being able to use and focus on existing lithium oxide metals. And so we really have been focused on using known chemistries, using our proprietary technology to really make an immediate impact into the cathode manufacturing process. Some of the proven benefits that we've been able to show is we can double the throughput of existing manufacturing by having a lot fewer steps and having it be a much faster process. We can show that we can significantly reduce the overall cost, and also the overall energy reduction is significant. And this all matters because of part of, the key elements of why we're all doing this is, one is to significantly reduce carbon emissions at scale. So at scale is a really key component that's been coming up in some of the dialogues today. And one of the elements is really driving down the cost, increases acceleration and adoption of these technologies to get on the market and replace traditional fuels themselves. And the way that we have done it, which has been, I think, a really big, important point, has de-risking the technology by really working with national labs and industry partners upfront, and really understanding how can we support the existing infrastructure and activities, and work off of that with our specific skill set to add immense value very quickly. So a couple of key learnings on when we really started to think about how do we get through the technology roadmap and the commercial roadmap to make an immediate impact. I really liked that one of the presenters, I think it was Maddie, that said, this is really the decade of scale, which is how we've really been thinking about ways that we think about our commercialization plan. And first, you have to de-risk the technology as fast as possible. This means you have to have early developments that can drop into existing applications. It's all an integrated battery source. We're focusing on lithium-ion batteries first, focusing on known cathode materials and the chemistries that are driving the marketplace in performance in the near term. So we're not actually focusing on forming novel cathode materials at this current point, although that's likely a potential in the future. We have established clear benchmarks for physical properties and performance benchmarks that have been verified by industry and also validated with third parties. So that really allows for an acceleration of the process. And we really rely on industry experts and internal labs for rapid assessment and feedback. So we've been able to, with the support and partnerships and collaborations we have in place with the national labs, we've been able to really create these feedback loops that create rapid assessments and feedback for our developments and optimization. And then the second, which I know this is probably quite obvious, is everyone wants to commercialize as fast as possible. But with us, we really had to take a look at where are we creating value and how do we do that as fast as possible. So a big piece is enhancing, or really figuring out a way to work and integrate into the existing infrastructure. So we did that for lithium-ion battery because that's where we see a huge growth in the near-term future. And being able to integrate into the existing manufacturing process is going to be key for quick commercialization. Confirming target benchmarks with industry and what are the actual performance benchmarks that are needed for sort of end OEMs to see. And if you're trying to actually have better performance, what are those better performance benchmarks that are going to accelerate the adoption and get the industry excited. And then last but not least is really knowing and testing your value. So this has been key for us as we have developed our pathway towards our technical and commercial efforts, is really accelerating our time to market and maximizing the value for industry. So how do we know and test our value? we have spent a huge amount of time developing key partnerships with the national labs. We've gone through proof of concept with funding from NSF, USDA, Molecular Foundry, and really expanded with optimization and validation with Berkeley Labs, CalCharge, Argonne Labs, Spectra Power, and then most recently we were an awardee, or our awardee, of the DOE Advanced Manufacturing Grant. So we're really excited to be now moving towards optimization and validation stage and scaling up and validating our technology. And we've created this really nice feedback loop with commercial partners and early industry partners to validate all of the key points that really expedite our commercialization by scaling and de-risking with government support and through the national lab collaborations. It just has been monumental. So I know we're going to be getting into deeper discussion, which I look forward to having. But to sort of reiterate off of some of the points that Jeff and other colleagues made, we do have, and many companies have the ability to be a billion-dollar company while really reducing tens of thousands of gigatons within the next few decades of CO2. So I think that's really monumental, and our success and the success, I think, of many companies in the space is reliant on these key partnerships early up front to expedite the developments. Thank you so much, and I look forward to connecting more.
Thanks, Virginia, for an excellent presentation. Yeah, and I think it really dovetailed well with some of the ideas that were laid out previously. We're going to start with a few questions, and if audience members have questions, feel free to post them, and we'll weave that into the discussion as well. I think the first question, this was kind of touched on a little bit by some of the speakers, but if maybe each of you want to talk a bit more about what you see as sort of the immediate need, given the scale of the opportunity, the challenge, like what do you, from your vantage point, what do you see as like the most immediate need? And maybe we'll start with Virginia, with you, if you want to.
Perfect. Yeah. No, I think I think this panel did a great job of laying that foundation. But for a company and an innovator, what you really need to see is a pathway for how are you getting through de-risking the technology and commercializing as fast as possible from well to wheel, right? So I think Jeff did a great job of trying to, of pinpointing where companies meet this inflection point. But I know it's a couple words, but that's actually really hard to do, is figure out what is that inflection point and what does it mean for your technology? And there's a lot of different pieces of the puzzle. So really getting into more distinction class and validating the different parts of the inflection points or the different ways we can get to market in this booming economy, right? So we're also working with a lot of changing landscape. It's changing in our favor, which is great. But I think that that's something that when we're trying to own the story and educate, I think some financiers that are coming into the space, that's a little bit more complex, is getting them to up that learning curve. So maybe we can get Jeff to put some presentations out there.
I do have a dovetail to what you just said, Virginia, and that is that my short answer to your question, Stephen, is that there's two things that define that inflection point. When is a startup penetrating the market, and what does their supply chain look like? That there's an evolution of cost of goods sold that is driven by scale. And so where the government, when you say, what can we do to help? I assume you mean DOE. What the government could do is what you've already started to do, but to double and triple down. That Natron, we're an investor in Natron. It's extraordinarily helpful. The government can't really help too much with market penetration, right? With policy, maybe at FERC or something like that, new rules at FERC could help. But the key thing the government could do is help shore up the value chain. Again, I think I'm telling you nothing that's a surprise, but get grants out there, like Virginia is saying, to help more rapidly scale, and not just scale from gram to kilogram to tonnage quantities, but scaling the operation. That's capital that's very difficult to come by from the private markets. It would really ease the entire equation if the government doubles down on what they've already started, and that is to fill factories with equipment.
Tony, do you have any thoughts related to that question?
Sure, I'll reiterate a little bit on that. And at the national labs, like we do a lot of work on trying to understand the fundamental science and push things to a certain level However, when we become close to the prototype level, our funding opportunities decrease significantly. So such things as CalCharge or finding an industrial partner is very important to us in that respect, because these are areas where we get to a certain level, we've got a material system, and it could just drop if we don't have the right connections or companies or partners to push it to the next level. So that prototyping step is where we see, at least from my point of view, I'm going to make it personal only, is that's that gap that we're missing, and that's where we really like the efforts that are being put forward here at CalCharge and basically the infrastructure of this meeting.
Danny, do you have any thoughts you'd like to add to that?
I'd just refer back to something that Maddie Tyson said at the presentation from Rocky Mountain Institute, that I think the US needs a more complete strategic view and direction stated. There's RD&D now, systems for supporting that. There's the demonstration commercialization stuff we're talking about here with the Energy Storage Grand Challenge. And there's demand being generated by the market, by policy, by people pull. We really need to focus on the scaled manufacturing and supply chain piece, I think, next, in order to catch up. I mean, the fact is the US is being left behind by the month by Europe, China, even India in this game, and I think we've got to get onto it.
Danny, it's a good point. If I may clarify what I said earlier, Natron has received an award to build a specific battery for a specific market. But more broadly, to Danny's point, there are 5 really big battery cell makers in the world, right? 3 in South Korea, LG Chem, Samsung, SK, Panasonic in Japan, and CATL in China. They account for, I don't remember the numbers, 80 or 90+% of all of the manufacturing of battery cells. So one thing is to help companies like Virginia's achieve scale. Another thing is to attract those very large behemoths to the US to build their plants here in the US. And they could not only create localized economic booms, but they can create avenues for startups like Virginia in the US to establish, penetrate the value chain above them. So it's a combination of helping the startups themselves, but also encouraging those large entities to come and build their plants here in the US.
That's really interesting. Actually, that's sort of a segue in my mind as far as so the global context. This panel is California Leads. I wondered if each of you could talk a bit more about how you, again, from like your personal and entity's perspective, how does region and location affect your strategy or how you approach things? If you can invest in a company wherever it is, or you could locate your supply chain wherever it is, how does that sort of California dimension affect your decision making or your strategy? And maybe let's start with Virginia again, if you don't mind.
Yeah, no. Excited to answer this. So I think it's a threefold for us: talent, just amazing people here; mindset, the potential to actually think you can create substantial change and go out and do anything that you put your mind to. I think that's really key. And then third, but probably the most important, is the access to the early development and the access to the national labs that is just really saves you tons of upfront capital to prove out and test out initial developments and evaluations, so you can take that immediate risk. So I think that for us, that is the reasons that we are here and why we have maintained our growth model in the Bay Area.
I have an anecdote that's illustrative. I was at one of the largest oil and gas conferences in the world in Norway a couple of years ago, and an executive from BMW was presenting, and one graph they showed had on the y-axis sales of electric vehicles, and on the x-axis some version of what are the incentives. So they were trying to show that there's incentive-driven sales. And I looked, and what they did, each data point was a flag from a nation, and I could not find the US flag on the graphic. Ultimately, I found the California state flag on the graphic, up there with China and India and the United Kingdom and Germany. And I asked him later, I said, hey, I noticed you had California up there and not the US. He said, yeah, well, that's our market. And he was joking, but my point of the anecdote is, from the investor's perspective here in the US, I'll tell you, I'm old enough in my 50s to have seen over and over and over that California leads. It's a good name of the event we're doing here today. What California does, the nation will do. It's only a matter of time. So from an investor's perspective, first of all, Virginia's right. The talent in the U.S., the inventiveness in the U.S., the ability to create truly differentiated intellectual property that disrupts markets, a lot of that is U.S. based and incredibly important. But we look to California as investors to say, what's coming in the U.S. market, right? We can see the European markets, we can see the Asian markets. When we think about the U.S. market, we do focus on California.
Great.
I just say from sort of the point of view of like ecosystem and driving this innovation and building equity of the global clean economy, which is our mission at New Energy Nexus, California is like front and center of the world, to all the points Jeff and Virginia just made. You know, all that sort of sits in the kind of bucket of natural competitive advantage in economic terms. We've got a couple extra things to mention, though. We're the western state of the United States facing Asia, where the demand is. You know, not only supply, but also growth in economies, in markets for the products. The 50% of the world's middle class is on the other side of the Pacific from where I'm sitting today. And that's only going to grow, obviously. The other point is our amazing resource here in state, which we're going to talk about in the next panel, just to do a little ad around the lithium supply we have domestically in the United States. You know, this whole conversation about at least lithium chemistry batteries needs a raw material. And if we do all these things we dream about, the electrification of transportation using spodumene-based lithium from Australia that goes through China to be processed and refined and so forth, or brines from South America, the carbon footprint improvements are they're not entirely nixed, but they're massively reduced. And so we have this big competitive advantage now for this work, the Energy Storage Grand Challenge in California, in the form of Lithium Valley, which I just wanted to put out there.
Great, thank you. And Tony, from the National Lab perspective, what are your thoughts on the role of the region? You know, there's multiple labs, a lot of activity. How does that inform your thinking?
So it's twofold, and again, I'm going to speak from my personal experience at the lab. Is that having the Bay Area as next door neighbors, it gives us this pool of very talented people. So as I talked in my presentation, the spin out, spin in, particularly with respect to attracting talented scientists, is very compelling. Just to give you again an anecdote from Jeff, we would put a posting up for a position of printing materials for energy storage or carbon capture, and we'll get 400, 500 applicants. And we have a similar posting where we're printing, let's say, more esoteric materials for the lab, and we get maybe 10 or 15. And the relationship between the two, the technology and the science, is very similar. So having this pool of talented people to attract from is one of the real drivers for us in this area.
That's great. Thank you. So we touched on this a little bit, but maybe I wanted to see if anyone else had other thoughts on, I think, Virginia, you were talking, either you or Jeff were talking about the need to get to scale, and that's really this focus about getting to scale. And I think, Jeff, you also kind of highlighted that that's another big way to bring costs down. And so beyond anything that someone's mentioned so far, do you have other thoughts on maybe gaps in the current U.S. system or strategy where there's opportunities to accelerate that commercialization or that scale that is going to be required?
I'll just mention a little bit from sort of the entrepreneur's perspective is, when you're thinking and innovating sort of new and novel, the most extreme edge you can get to always seems the most sexiest, like the most exciting. But when you're actually trying to couple that with how do you get to commercialization and make money as fast as possible and solve big problems that are currently on the threshold of exponential growth, you have to think differently. So you have to think, how can I create a solution that has the ability to, have substantial change. And to Jeff's point, is novel intellectual property and developments, and it has that ability to grow in that capacity and be strong there, but also be able to make that immediate impact. So I think that is it's more of a mindset about what you're trying to do, and then how do you think about that in your trajectory of your technical plan of how your first sort of prototypes and developments, and then how do you expand that into the commercialization and the scale up, because it trickles backwards, right? So for those of you who are on the call and are in the early stages, I definitely would look at and map out your technology development plan and your scale up plan, and to Jeff's point, even your exit plan, because then that really helps you trickle down backwards of what you're trying to prove out, who you're trying to talk to within the whole convoluted value chain, and manage through that process in a much more exponential way.
That's a great point. Anyone else have thoughts on that front they'd like to share?
Incenting adoption, Stephen. I know it's difficult to do and is only, slightly under the DOE umbrella, but yes, I would press on helping companies scale, right, in the form of grant capital, but government grants. But there's also incenting the adoption, right? There's a real issue on the grid right now as to the FERC rules. So whatever the Department of Energy's role is in interacting with FERC, I think, and again, I'm not saying anything you don't already know, but if we could change the incentive structure for the utilities so that efficiency and lower carbon usage, but even if you put lower carbon usage to the side and just reward efficiency economically, which it essentially is not currently, that could drive adoption in a way that the second part of that equation, first part being economies of scale, cost of goods sold, but that's connected deeply to adoption rates.
Danny or Tony, do you have anything you want to share? Danny?
No, just concurring. Absolutely.
So we did get a sort of a kind of a related question from the audience about, this was directed at Jeff, maybe others want to weigh in about, discuss the importance of the intellectual property portfolio of a prospective startup investment for Volta. And maybe others might have thoughts as well on how IP fits in all this.
It's vital. If I may jump in, it's vital to early on identify which of your intellectual property is most valuable and protect it. But it's also vital to scan the landscape and do a professional job of understanding where your intellectual property fits in the landscape and where there are existing gaps that you could fill. Because that's where all the value is. What I mentioned earlier about there's a parallel to integrate the circuit industry in the 1980s and 1990s. That parallel exists. Volta is co-investing alongside LG Chem and Samsung and BMW and Nissan and Hyundai and Ford and Umicore and Solvay. The list goes on and on and on, because they are so focused on scaling for this massive market boom that's happening that they have rightly, in my opinion, outsourced innovation. So if they've outsourced innovation, you must corral and protect your own intellectual property in order to aim for a valuable acquisition into that value chain later. I can't stress enough how important that is to protect your intellectual property.
Great. So we only have about 5 minutes left. I think one question I had, again, not to show my DOE bias, but given, Tony, your representation of Livermore, and Jeff, your time at Argonne, and Virginia, you highlighted, your connections labs. Do you have any thoughts about the relationship between these companies and the lab complex and opportunities to better facilitate that transfer of whether it's intellectual property or expertise or user facilities, where people, I think, often don't realize that the labs have capabilities to test out technologies? Given your experiences and your perspective, do you have any thoughts on opportunities that should be pursued in that?
I'll jump in real quick, because I was just thinking about this. The honest truth is, I think the other entrepreneurs who have used sort of early incubator, early foundry areas in the national labs have been monumental. So I probably have a handful of founders from a lot of the companies, Cornshell, Sepion, that were mentioned here today that have really helped us, and we just collaborate a lot, right? So we talk a lot. So I think that getting all us into the room and figuring out what's working and what's not working and who's worked well throughout the different programs, I think would be key, along with the program administrators, just because I think that we already are doing that and collaborating so intensely on the side.
Great. Any other thoughts?
It's an age-old problem, right? When I was at Argonne, I struggled to write the contracts. I mean, I love hearing about these spin-in, spin-out ideas. I mean, my answer is just continue to press the gas pedal on things like the spin-in, spin-out capability that Livermore has, that Tony described, meaning it's cumbersome to create a contract, and it's expensive in many cases for startups to use. So whatever the DOE can do to expedite that. For example, Volta has a contract with Argonne that's a CRADA. Our startups and our portfolio companies can use our CRADA. And so, there's no contractual exercise that's required that can take 9 months and mount a significant legal expense. So the more the government can do with opening the channels for ease of access to the startups, and potentially fund them through things like tech to market, right? There are these funding mechanisms inside the Department of Energy, in your office, I think, Stephen, like tech to market, where if you could help those startups gain access to the national lab and fund that research, right, through a cooperative agreement, funding part of that research, I think those are the answers to the question.
I'll just reinforce that again. Sorry, Virginia, if I may just maybe get you to talk to this afterwards. But like Volta at Argonne, CalCharge has a CRADA with both Lawrence Livermore, Lawrence Berkeley, similar terms where you can step into our shoes as a legal matter as a member of CalCharge and therefore access the lab more simply, and this sort of expedited entry into these incredible resources. I mean, look at Lawrence Livermore, what the director showed us this morning, this high performance computing capability and all the incredible stuff that's now becoming more open campus outside the fence line, as it were.
CalCharge was the model for us. I should have said that, Danny.
No worries. I just want to make sure that particularly the entrepreneurs listening to this, there's all these young engineers and people coming out of the university system and hopefully higher up the food chain, like the Assistant Deputy Secretary was talking about. They should know that we do exist to serve, and these communities and ecosystems of support do happen. And then the magic really starts to kick in, which is what Virginia described. Sepion, Corshell, and Silvertex, they're all CalSeed and CalCharge companies. They're all going into the labs using our CRADA and benefiting from grants we get from the CEC and stuff. But the real magic is when they start working with one another and forming teams and maybe merging and supporting that creative process, the synergy that occurs between entrepreneurs in this sort of structured serendipity. That the U.S. Department of Energy National Lab System is the largest of those ecosystems for structured serendipity in the world, and we just have to mash that together and make it happen faster.
Perfectly said, and that's exactly what I was going to share. So well done. The only thing is, it sounds like, Danny, you need to raise another venture fund through CalCharge, huh?
Sure.
We all need that.
We'd be happy to.
Thank you to such an esteemed panel. I think it was really appreciate all your perspectives. Really great discussion. Obviously, a lot of work to do and a lot of potential. Thank you, everyone, for watching and your participation. Now we'll transition to the networking feature here in Hopin. If you weren't here when Danny introduced it at the beginning, you'll find the networking tab on the left side of your screen. So with that, sort of a virtual round of applause for our panelists, and thank you everyone for. I'm sorry, Dan, you have something you wanted to add?
Just a sort of direction also, there's an option, networking or the expo. There are about a dozen fantastic posters that the PIs at Lawrence Livermore have prepared. Really amazing demonstrations of some of the thinking and research and development going on at the labs and elsewhere. So you get a choice. You can either go network and find someone for 3 minutes and just hopefully bump into someone you didn't know, or you can go look at these posters, or you can do both. Move around like you were at a conference, go outside, go to the bathroom, get yourself some lunch, and be back for the next session. But please, thank you, Stephen. Sorry to interrupt.
Yeah, no